Entanglement is when you take two separate entities, two separate bodies. So just imagine maybe some particle over here and some particle over there. You can look at this particle and, you can measure its quality. If it's like a pen or a pencil, maybe the pencil is pointing up, maybe it's pointing down, and here's another pencil, maybe that pencil is pointing up, maybe that pencil is pointing down. And entanglement is when you can synchronize their qualities to a point where if one is pointing up, it has to be that the other is pointing up. And if the second is pointing down, the other has to be pointing down. But you don't know in advance. So it's random here, but it's never random here. It's always the same as this result. And when you check this property for atoms or molecules, it works. It works remarkably. So one way to deal with this is to do theory and think about it and come up with explanations as to why something is not possible or is possible. But another way, which is the approach that I've taken along with our colleagues, is to try. Just to take objects that are bigger and bigger and bigger and bigger and put them in non-classical states and see if it works. If it works, we've just pushed the boundaries on what can be quantum. And so during my PhD, I did it with an atom and a photon, two very small objects. Then I did it with an atom and another atom. And this recent work is with a mechanical drum and another mechanical drum. Each one of them has 1 trillion atoms. And if you look at their size scale, it's roughly the diameter of a human hair. So it's still small, but it's, the diameter of a hair. It's something that you can sense, that you can feel. And then having these two macroscopic objects, they're no longer microscopic, and have them be entangled was the challenge. The question was, can we do it? Can we devise an experiment that actually tests and pushes the boundary in quantum mechanics? And it took 4 years and a lot of failures, to be honest. But in the end, it worked. We could see quantum mechanical behavior at the macroscopic scale. One interesting fact is that this experiment is a realization of the original thought experiment conceived by Einstein, Podolsky, and Rosen about 100 years ago, also known as the EPR paradox. And basically their idea was that you will not be able to see entanglement, definitely at all, and definitely not for macroscopic objects. And they were right to point out that it is a very funny quality of quantum mechanics, and they were wrong about the fact that it's not possible. This experiment is one of the possible realizations of the EPR paradox, which is not a paradox, it's actually possible. That's it.